Hello everyone, welcome back. So we are going to do the next set of questions, that is question number 11 to question number 15 of the organic chemistry part of the CSIR 2021 June question paper, right? So let's look at the question. The question says the major product formed in the following reaction is. So you are having a vinyl halide plus you are having Grignard reagent PHMgBr in presence of palladium complex. So it very clearly it looks like pH MgBr is there. So pH is having negative polarity, magnesium is having positive polarity. So this pH would go and attack the carbon, vinylic carbon, and the Cl minus will leave and this reaction occurs. So you are right in that place. Only problem is on vinylic system this reaction does not occur. Nucleophilic substitution cannot occur because of various factors. Let's not discuss on that, but yeah, so that's why we are using what is called as palladium tetraphenyl phosphine complex. Now this is called as Kumada coupling. It is used for alkyl vinyl and aryl halides with palladium or nickel catalysis. It is used for coupling reaction. So let's go step by step. So in the first step you are adding palladium 0 complex. So you know palladium comes under nickel. Nickel, what's the atomic number? 28. So its configuration will be, if it is 28, 2 and 8. So if it is 8, so you will be having D8, 3D8 here because it is nickel, 3D8, 4S0, 4S0. So that comes to 10 electrons. So it is 10 electron system. So when you come from nickel to palladium, it will have 4D8 and 5S2. So it will have 10 electrons. And each PPS3 will give 2 electrons, so it is having 18 electrons. Now 18 electrons is non-reactive system, so first it will undergo oxidative coupling and 2 of the PPS3 gets out and we get this palladium 2 complex, right? Now when it becomes palladium 2 complex, please understand, now it is having 2 less electrons, so it has become 16 electrons. Now it is reactive system, it will react furthermore. Now how does it look like? It pretty much looks like your Grignard complex kind of stuff. You are having palladium which is having positive, so of course carbon will having kind of negative. So before this reaction occurs, what will happen here is, first there will be a transmetallation, because clear cut palladium has positive charge and it is 16 electrons, it is reactive. So substitution reaction occurs. pH minus is a good nucleophile, Cl minus is a wonderful leaving group, and therefore this reaction occurs and you are getting this. Please see the symmetry is maintained. Now what happens thereafter is pretty much like this. It is plus, so it will go and attack the this palladium is plus, so it is kind of negative. This will go and attack here and this will get out here and you get something reaction like this. So coupling has occurred. You are able to add this phenyl group from the another phenyl, so which was already having negative polarity. So important point is this coupling has occurred. Whenever it occurred, this double bond was never compromised. Never ever this double bond became single bond character, got single bond character, and therefore because it was cis, the addition of palladium occurred in cis form, and so the product also remains in cis form. Thus the answer is option number B. Okay, let us look at the options. I'm sorry for that. Let's look at the options. So this B is the answer. Let's move ahead. Next question. Next question says the pKa of the following compound is in the order. Now this is tough question. Looks very easy, but it's quite complicated question. Okay. So you know what is pKa? pKa is negative log of Ka. So of course pKa is inversely proportional to Ka because it is negative log. Negative term is there. So Ka is acidity. Whichever has higher acidity, whichever proton is more acidic, that will have higher Ka value, and that means it will have lower pK value. So if you look here between A and B, it's very easy to find out, because here if you see these protons, if I remove this proton, it has two protons. Imagine I removed one of the proton, you get a negative charge. So this negative charge is delocalized over this side, so that you get minus charge delocalized over this oxygen. Also you will get delocalized over this oxygen. So you are having see, it's the negative charges which is making it unstable. So you want as less negative charge to be there on this carbon. So when these oxygens are in conjugation, so it's like even if you imagine all of them has same electronegativity, carbon should have 1/3 negative charge. Actually, it will have much lesser than negative charge because oxygen will stabilize negative charge better than carbon because oxygen is more electronegative. Whereas here problem is all that I said exists for this also, only problem is there is a counter resonance here, counter conjugation here. So this oxygen pumps electron to this uh, pi star molecular orbital of this p double bond O, and thus this goes up. So the capacity to accept electrons from here reduces. The capacity to accept electrons from here dramatically reduces because oxygen is donating electron. So very clearly this is more acidic than this. So that means Ka of A is higher, Ka of B is lower. That means pK of B is higher and pKa of A is lower. Now C is the tricky part. Till now it's like children's work, small work it is, but C is what is interesting, where they are looking at your understanding. So please understand, it is a 6-membered ring. So how does 6-membered ring generally exist? It will exist in chair conformation. Let's look at it. Yeah, so this was the cross conjugation I was talking about, and because of that the tendency to accept this electron reduces. Yeah, now when it is 6-membered ring, it exists in chair conformation. So what happens is, when you are having chair conformation, you see here negative charge, double bond O, and then oxygen is there. So we expected pretty much like ester, it should be lesser acidic. We would have expected this lone pair will come and attack here and cross conjugation would occur, and therefore it should be less acidic than your compound A, where it was just ketone, it was not ester. But interesting thing is, when it exists in chair conformation, this oxygen is like this. So the lone pair is in this direction. You can see very clearly one lone pair is here, another lone pair will be inside the board, inside the screen, but it is not parallel to your anti-bonding. It is not parallel to your anti-bonding pi star molecular orbital. So they do not overlap at all. There is no overlap at all. So what happens? Resonance effect has gone, but inductive effect is still there. Oxygen, we know it is electron withdrawing group because of its electronegativity, minus I effect. So it does not show any plus R effect, but it is showing minus R effect. Because this, what happens, it makes it more electronegative. This carbon is more electron deficient, and therefore it will stabilize the negative charge better than even 1. So C will be most acidic. So C will have least pKa value. So the answer will be C will have least, then we'll have A second lower pKa, and then B. Therefore the answer is D. I hope it is very clear. I will go once again slowly through it. You can read it, you can pause it also. Okay, please read through it. Whatever I said, I have written here in great details. Yeah, next question. The ozonolysis of hydrocarbon in presence of water produces pentanoic acid and carbonic acid. Now this is the simplest question possible. So of course hexene, if you do ozonolysis, you get a carbonyl group, aldehyde or ketone, you don't get acid. But here they are giving you pentanoic acid, carboxylic acid, and another one is also acid. So it has to be alkyne. So it either hexine or decyne, 5-decyne. So very clearly it is a hexine, because once you cleave this, so both the end will become carboxylic acid. So this end becomes carboxylic acid and you get pentanoic acid, and this end also becomes carboxylic acid. Now because it is only one carbon, it becomes carbonic acid. So the mechanism is basically, first it gets oxidized, both side become aldehyde. So both side become carbonyl. So this part becomes ketone, this part becomes aldehyde, and then when you hydrolyze it, you get pentanoic acid and carbonic acid. Thus the answer is option number B. The next question, the following transformation example of, now this is very simple question, it's a pericyclic reaction, cycloaddition. It's asking 3n plus 2n or 8n plus 2n plus or 6n plus 2n or 8n plus 4n. So basically benzene, you know, benzene, the benzene ring has different conjugation, and this pi, this extra pi bond, it's not exactly pi bond, yeah, but the extra bond which is there uh, is perpendicular to the p orbitals of the pi Molch orbital of the benzene ring, and this acts as separate pi bond, and therefore it acts as 2n system. So very clearly answer will be either A or O. It will be either A or B or C. D we can remove. Then attacks here. So this is a very simple reaction. You can look here. This comes here. This comes here. This comes here. 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 Here, since 8 electrons are involved, so it is 8 plus 2. So the answer is option C, 8n plus 2n. Let's look at the last question. This is very interesting. It's very similar to the previous video which we did. So here they want you to find out C13 NMR spectrum of TiCl3 CdH2. Okay, they are asking which pattern fits in well. Maybe yeah. So and they are saying that CH coupling is greater than JH coupling than CD coupling. So let's understand this part. Hydrogen couples more than deuterium. So C13 will be first in this compound. This C carbon will be first split by hydrogen. So how many hydrogens are there? 2 hydrogens. So how much it will split? 2 plus 1. So that will come as triplet. So first it will split into triplet. And triplet, how we know? It follows the Pascal's rule. So if it is 1, so doublet will be of the ratio 1:1. Triplet will be of the ratio 1:2:1. So the first triplet will be 1:2:1. So something like this. Okay, like this will be your first splitting. Second splitting, what happens? Now D is coupling. So D we know 2Ni plus 1 we did in the previous question. For D, I value is 1, not half like hydrogen. So even if 1 deuterium is there, so 2Ni plus 1, that's the formula. So for hydrogen also we use the same formula, but basically for hydrogen I was half. So for hydrogen became 2 into n. N is number of hydrogen, that was 2. 2 into 2, 4 into half. So when you do 4 times half, it becomes 2. 2 plus 1, 3. That's why triplet came. But now deuterium is having IS1 value. So number of deuterium is 1. So 2 into 1 into 1, that is 2 plus 1, it is 3. Now it will again split into triplet. So the answer is triplet of triplet. But with all of the options given, okay, at least A, B and D are given triplet of triplet. We want to know what's the height, what's the ratio. So I had said this previously also, the coupling, the pattern here is 1:1:1. So triplet is not 1:2:1, it is 1:1:1. So what happened? First it already got split into this, then when it is splitting triplet, all will have same height. So the answer will clearly be option B, because here we are having 1:2:1, and then all of them are split into equal. So answer is option B. So whatever I said is written here, you can go slowly through it. Okay, answer is option B. So that's it for today's class, and we'll do the next class soon. Thank you.